This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 9, Clutches and Brakes. A disc clutch that couples two shafts and a disc brake that stops one against ground are the very same mechanics. A ring-shaped friction pad, squeezed by an actuating force, carrying torque. The handbook gives one table with two columns: uniform wear and uniform pressure. New parts run at uniform pressure. Once they bed in, they settle to uniform wear. This is a light lesson. Read the table off the page, pick the right column, and know which one a careful design leans on. Concept 1. One annulus, two models. A clutch ties two rotating parts together. A brake ties one to ground. Both are the same thing. A ring of friction material, inner diameter D, outer diameter D, squeezed by an actuating force and carrying torque. The torque it must handle is the shaft torque from Lesson 1. Now, how is the pressure spread across that ring? Brand new flat parts touch evenly, uniform pressure at the maximum everywhere. But wear follows pressure times radius. So as the pad beds in, it settles until pressure times radius is constant. That's uniform wear, and it makes the pressure spike at the inner edge, the smallest radius. Uniform wear has a smaller effective radius, so it predicts less torque, which makes it the conservative model, and also the one a worn-in part truly follows. Concept 2. The handbook's one table. Two rows, two columns. The top row is the actuating force F, the bottom row is the torque T. The left column is uniform wear, the right is uniform pressure. Pmax is the maximum pressure, F is the coefficient of friction, and D are the outer and inner diameters of the pad. The one rule that matters: each torque uses the force from its own column, never cross them. And if you factor each torque as F times an effective radius, the wear radius is simply the mean of the two radii, while the pressure radius is a little larger, so uniform wear always lands on the smaller torque. Setup. The worked problem. A disc clutch has a 6-inch outer diameter and a 3-inch inner diameter. The lining is good for 100 psi with a friction coefficient of 0.3. Find the actuating force and the transmitted torque under both models, and then decide which torque a conservative design should quote. The one thing to watch going in: D in these formulas are diameters, so the 6 and the 3 go straight in, no converting to radii. Solve. Both models at the same maximum pressure. Under uniform wear, the actuating force comes to about 1,400 pounds, and the torque to about 950. Under uniform pressure, the force is about 2,100 and the torque about 1,500. Notice the wear column is lower on both counts. Smaller force and smaller torque. So a conservative clutch is rated on the wear torque, roughly 950. And you can check either torque as force times friction times an effective radius. The wear radius is the mean radius, 2¼ inches. The pressure radius is a touch larger. Traps. 5 ways this bites. 1. D are diameters, so don't have them to radii. 2. Don't mix columns. Each torque uses the force from its own model. 3. Worn in, bedded in, or conservative all point to the uniform wear column, because it gives the lower torque. 4. Under uniform wear, the peak pressure is at the inner radius, so that's where the lining is checked. And 5. The actuating force is the axial squeeze, not the friction force. It becomes torque only after you multiply by the friction coefficient and the effective radius. Quick recall. A clutch and a brake are one friction annulus. The P198 table gives the actuating force and the torque in two columns: uniform wear and uniform pressure. And you keep each torque paired with the force from its own column. Factor a torque as force times friction times an effective radius, and the wear radius is just the mean radius. New parts use uniform pressure. Worn-in or conservative designs use uniform wear, which gives the lower torque. Watch that D are diameters and that peak pressure sits at the inner radius. Golden rule: same annulus, right column, force and torque together, and report the wear torque when it has to be safe. Next up, Lesson 10, Exam Strategy, and it closes out Week 4. Together, these lessons have covered the whole power transmission chain: shafts and keys, bearings, power screws, the gear family, planetary trains, belts and chains, and now clutches and brakes. Lesson 10 pulls them together for the exam. How these problems are framed, how to recognize which element and which relation a question is really after, and how to move quickly through Section 216 under time pressure. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.